Hello, and welcome to the STS maintenance software training. Today I'll be showing you some of the key features of the maintenance software and how it can help you maintain your STS system. So first, to start out with, you have three different types of testers: a T1 in the center, a T2 on the left, and a T4 on the right. Today we're going to focus on the T2. So in this video, you can see that a T2 is being created. There's PXI instrumentation inside the test head, in this case 2 chassis full of instruments. The cables are connected to the top of the test head, pogo pins at the top. Load board then gets set down on top of the tester. Then you can pick it up with a manipulator and set it down into either a prober or connect it to a handler of some kind. I've just recently restarted my T2 system. The first thing that you notice is that the maintenance software comes up automatically and right away. This is the default behavior of the maintenance software. What the maintenance software is doing right now, it's actually checking the configuration to make sure the tester is in the exact configuration that it's supposed to be in, and also updating the name of the instruments so that the test programs that are configured to run on this tester all run okay. It's going to do something else. It's executing internal power on tests on all the instrumentation to make sure they're in a fairly known good state at this moment. There's going to be some more advanced things we can do once the maintenance software finishes its routines here. And so as you see at the bottom there, you have a picture of the tester itself. That is an actual representation of the picture of the tester that you have. So the maintenance software is now finished. So notice that it says system OK. It has done all the things that it can do during power up to check to make sure the system's all right, and it's letting you know that. A couple more things. If the IT department that you have at your facility doesn't allow the maintenance software to start up right away, you can get to it. There's a shortcut on the desktop. You can also go to the Start menu to activate the maintenance software as well and bring that up at any time. Let's talk about some of the features and the layout of the maintenance software from this view. Again, this is kind of the 10-foot view. Shows you a little bit about the overall status of the tester. You can see the name of the tester. So this is a T2, and my tester name is ni-sts-t2, and then my IP address to the external network is indicated here. Again, this will be determined by the factory and the IT department that you have there. A couple other things to mention. There's many tabs here that we'll go through over the course of this video. You have an overview, system details, load board, spring pins, chassis, and instruments. And again, we'll kind of walk through either one of those and what they do. You can also see who's logged in. Right now I'm logged in as an operator. You can see the date and time and also the version of the maintenance software. So on the far right, here's the version of the maintenance software. The next button that I'll show you is this help button here. So if you click on the help button, it's going to open an HTML help document that has virtually everything that we're going to discuss here in the maintenance video today. One of the key ones that I want to point out is the user interface details. If you have someone new that wants to look through some of the documentation, this is a good place to have them start. It's actually a step-by-step of what some of the different features the maintenance software can do. Right, so if you see this first picture on the bottom right, it shows how the maintenance software runs in the task manager, how to launch it from the start menu and from the desktop. And if you click through the different options, it'll show you exactly, here's the parallel and self-test. It talks about the different things that you can do there, overview, and it keeps going on through the different things that we have. So let's keep going through the maintenance software personally. This is a good resource to know that it's there. Some of the other common things you might want to be able to do, there's a login. We'll talk about that here in just a minute. There's also open report directory. So whenever we run a routine like continuity, functionality, or checker, or anything like that, they all get saved to this report directory, and you can do that. This is another good one, generate system report. So if you want to do that, this actually kind of gives you a snapshot of the tester. It's going to save an HTML file on your desktop. It's going to be a little bit of information about the tester, right? So what kind of a type of tester it is, its serial number, revision, things like that, so that you can know and give this to your maintenance team or documentation for everything you need to know. You scroll down a little bit here, it shows you all the PXI instrumentation, what's their current temperature, their serial numbers, the name of the instrument, things of that nature. So this will also be good to give some of the test engineers as they're developing their test programs to know all the names of the instrumentation, what pogo slots they're in, and what kind of a resource they are. Alright, the next thing that I want to show you, we've kind of covered the main section here. The next thing I want to show you is the System Details tab. So this is kind of a little more generically about the system, right? So on the top left here, you've got a picture of the bottom of the tester. So this is the bottom of the T2, and it shows you all the different fans that we have and all of their RPM speeds at the moment. The nice thing about this view is if any of those RPM speeds start to go down, you'll have they'll be indicated by a red color to indicate that either you need to change the fan filters or check on those fans to make sure they're operating properly. Below that you have the different type of testers, so it's a T2DX. Again, some more information here about the system itself. The center cavity fan, so this fan speed right here is for the center cavity fans. One of the nice things about STS is that customers can put third-party instrumentation inside the middle of the tester, and we want to give you flexibility to control those fans as needed. It shows you the state of the DIB locker and whether there's a load board loaded, the firmware of the tester, and the nice thing at the bottom here is you've got current runtime, which is how long it's been running since I started up the tester, and then total runtime. The next thing we want to show you is PXI controller information. You've got some of the information about the host name, the different CPUs, how much network capability there is, and obviously hard drive and memory capacity. The next thing we have is power supplies. These are internal power supplies to the tester. So inside the test head there is voltage rails that can be used. 48 and a couple of 12-volt rails. And the 48 has the ability to enable or disable. It's also because that is used to power one of our RF calibration load boards. And so that gives you the ability to turn that on here if you need to. The next thing is system temperature sensors. You have a couple of different sensors inside the test head, and these are their values and their limits. The limits are used because once we get to the upper and lower limit, we're going to give you information from the maintenance software telling you that, hey, the tester is either too hot or too cold to operate normally. And then once we hit those critical levels, the tester will actually shut itself off automatically to protect the instrumentation inside. The next thing, so that's kind of all that we have here for the overview tab. Again, you kind of notice that the name of the tester and the version and everything stays no matter which tab that you're on. So let's move on to the load board tab. So this load board tab is really just an information about the load board that's on the tester at this current time. What you'll see here from the description of this particular load board is that it is our STS DC calibration and checker board. But the test engineers will also use this ID prom to indicate what kind of a board they have on their testers. So for instance, if you have a tester that is hard docked to a handler and you can't see the actual physical board, you can look here to see what kind of board is indicated to be on the tester at the time. The next thing that I want to move on, this is probably the most important tab, the spring pins tab. This shows you a actually physical layout of the top of the tester. So you can see the different types of layouts, the different instruments that you have around the test head. Let me take a look at P142 for example. So P143 and P142 are two important pogo blocks. Those are what we call our system pogo blocks. On P143 you have your DMM. There's a 4110 power supply that gives you power to the top of the load board for controlling and powering load boards such as our DC calibration board, and then also some of the other system resources like I2C and things of that nature. P142 is our system SMU, and that gets used for a variety of reasons. We'll use the DMM to calibrate that SMU, and then we can use that P142 SMU as a calibration source for the rest of the tester. So if you right click on P142, you can see a few things. You notice in this particular configuration there's actually two instruments on it. But what you can do is you can actually do things on the entire block, like reset, self-test, self-cal, DC check, and verify as found. And then you can do that on the individual instruments if you want to. Some of the nice things I want to show you. So for instance, let's look at the pinout of this instrument. So it's a 4143 SMU on P142. And you can bring up this pinout. It shows you the PXI instrumentation on the left and what the front panel of it looks like. And then on the right hand side you can see the actual pins of the pogo block. And so if you're looking at the tester, you can see the guide pins for the orientation of the block. And then you can scroll to see what each pin does and where it's located. So for instance, pin A1 is a high sense pin for this 4143 instrumentation. So if you close this, you can go back, and let's say now I want to go ahead and reset that instrument just because I want to make sure that it's actually functioning and working okay. So you can right click on it, you can click the reset. What the maintenance software is doing right now is it's launching a routine to actually reset that instrument. And so this kind of gives you an idea of all the things you can do on an individual block. But now I think I want to go ahead and reset the whole tester. So let me go ahead and do that once this finishes up. So now that it's finished, it's going to show you a result window here. So you can actually click on this and you can scroll down into the different things to see what happens. What's really nice about this view, again, I'm not going to spend too much time here, but what you can do, you have this drop-down box on the right-hand side. If anything had failed, you could say show all, failed or error only, or passed only. So this kind of gives you a nice breakdown view if something actually does go wrong. So let's say I wanted to do a self-test on all the instrumentation. So I can click this button, and it will actually go do a self-test on every single instrument in the actual test head. And so again, that's what the maintenance software is doing, is creating a routine for what you just asked for it to do. And it's going to go through and self-execute. It does as much as it can in parallel, And basically a self-test here is just checking the communication across the PXI bus and making sure the instrument's able to communicate itself and who it is correctly, similar to what happened during the boot up of the actual tester. Again, it brings up this window here, and it shows you all of the different instrumentation that we just did a self-test on. So you can scroll through here and see these different things. You can even look at some of the test results on the individual steps that you click on if there is any information to show. You also have some step information as well. If we actually want to go look at a report for this, you notice you have a couple of reports that print out here. The typical one that everybody uses is the summary report. So if you click on summary and you can actually open the selected report from here, you can see that it's an HTML report that you can print out. It shows you the STS information, and then you can expand out to see what all was done. And so you can scroll through here and see all the different tests that were performed and on what different instrumentation. But if you just need a single printout, you can do this as well. So I know sometimes customers want to be able to print out a single page that shows what they just did. So let me close this up and close this. I want to go ahead and move on to the few of the other tabs real quick, and then we'll come back to this view in a little bit later time. So the next thing I want to show is the chassis view. So this is actually a really nice view. It shows the inside of the tester and what actual PXI instrumentation is inside this test head. So you can see on the right I've got my chassis. It's my chassis 1. It actually has the controller in it and all of its instrumentation. On the left we've got chassis 2 in bay 2, which is also shows that it's a PXI instrumentation. The nice thing here is that you can actually do the same things that you could do in the tab previous, in the Bring Pins tab. You can right click on these different instrumentations and do exactly what you need to here. So for instance, I want to see the pinout for this HSDO device. I can actually see the PXI instrumentation on the left and then the pinout for the instrumentation on the right. Again, if something's actually wrong with the tester, this will highlight red. If there's an issue like an over temp or an out of calibration, one of these instruments will light up red. I'm going to go ahead and move on to the instrument tab here. So if you look at the instrument tab, it's basically a list view of everything that we've talked about so far. Probably the more important or interesting fact about this one is that you can actually see more information about the instrument itself, right? So the current temperature, its external calibration date, and some of the self-calibration information. You can also see its pogo pin connection and location, serial number, instrument model, things of that nature. One of the nice things about this tab is that you can actually select more than one instrument. So let's say I wanted to test both of these at once. I could then right click and do all the different things that I can do on those two instrumentations together. So if I wanted to self-test both of these two, self-calibrate, run continuity, things like that. You'll notice I have two tabs here, right? So now I have chassis 1, bay 1, and then I have chassis 2, bay 2, right? So you can see this corresponds to the chassis view that we were just in. So bay 1 on the right here, bay 2 on the left. Same thing, right? I've got my chassis 2, bay 2, and chassis 1, bay 1. And so you can see the different instrumentation that also corresponds into this list view. Okay, now we're back on the Bring Pins tab. What we're going to do now is do some DC continuity and functionality checks. What this does is it checks continuity of the pogo pins of the tester to make sure that all the pogo pins are intact, there's no broken pogo pins or anything like that. The next thing is it also does a functionality check of the instrument. So it checks the hardware to make sure it performs the way it should, and also uses the software stack that the test engineers use as well. So for instance, what you can do at this point, you'll notice you have buttons here at the bottom, right? So you can do, we've talked about some of these other things that you can do, but if you notice on the left here, you can do DC check continuity all connectors. So that does the entire tester, as much of it as it possibly can. Another thing that you can do is you can be specific on the instrumentation. So you can actually come over here to the left side and you can select a specific instrument you want to work on. What we're going to do now is we're actually going to do continuity on the entire tester. So if I click this, what the maintenance software is going to do is launch a routine to actually check continuity on the entire tester. And so that's going to start up and show things in the middle of what it's doing. So for instance, it's going to tell you it's initializing, and then it will start to do its maintenance checks. What I'm going to do here in just a moment is explain what's going on in the center screen, but then also fast forward it so that we don't have to take up time in the video here. Continuity should take anywhere between 5 to 10 minutes depending on your configuration and your tester setup. And so that you can also have the option to cancel if you need to. So for instance, if you forgot to hook up something or you forgot to put the load board on, you can hit cancel if you need to. This software will also tell you if you don't have the correct load board on that you need to put on that specific load board. The first thing that it does is it resets all the instrumentation to get them ready and into a state so we can begin to check them correctly. So at this point I'm going to fast forward the video here to the end of the continuity routine.
Okay, so now you can see that my continuity routine is finished and the report window automatically popped up. So obviously this is an indication of what it looks like when you have a test that has failed. But what the good thing is here, we only have one thing that has actually failed. It's the 2567 block 1 continuity. And so you can actually click on this and you can see, channel 63, pin A1 and B2 possibly of the pogo pins. But you may be asking, which pins is that is that exactly? So you can actually pop up this pinout view and it'll actually show you exactly which pin has been broken or which pin is in question. So there's a couple of things you can do at this point. Obviously the easiest is to replace pogo pins. If that ends up not working, you then replace the cable, and then of course you can go all the way down to the module. And those are really the three things in the path all the way up to the top of the load board that you can change out. You can also try a different checkerboard if you have one of those available as well. So again, the first thing, like I mentioned, the easiest thing to do is to replace the pogo pin. So I'm going to do that now. Before I actually go and rerun the continuity routine, let me just explain a little bit more about this failed window here. So again, I mentioned before is that you can see the step down here and actually exactly which channel failed. But what instrument and pogo block is that? How did I know which pin to replace? If you click on the step information, you can see the instrument name, and because of the way we name our instruments in STS, you can see it's a relay driver. That's the model number 2567. It's in chassis 1 and slot 2 of that chassis. You can also see that it's in spring pin block P162. So there are a couple of ways that you can know which one it actually is that failed. You can also, again, this is filtering. It's only showing the errored or failed, but you can, if you want to, see all the past results. So if you want to see which ones actually did pass, you can see the rest of the tester that we ran, and you can see just the one that particularly failed and its name. So let's go ahead and step out of this, and as we mentioned when we started this, we did DC continuity all checkers, but we don't want to do that again because that's going to take a long time. So I can actually simply right click on the single block that we worked on, and you can say DC check that single block. So once I've selected that, it's now going to run a routine that only checks that one block. It has to rerun some basic system level checks to make sure that the checkerboard and the system and the SMU that we use to check this block are okay before continuing with that. And so that's what you're seeing it do now. Again, I'm going to fast forward the video here just to save some time. Okay, now I've finished running that single block and it has passed, so replacing that pogo pin was exactly what we needed to do. Again, you can kind of come to the actual instrumentation and you can view the pinout if you need to, and you can see the different pins that we've been able to fix. So everything's good now on this continuity. So that's how you can run continuity. Again, you can also use this view on the left here if you like. So you can click on the relay driver, and actually it allows you to run multiple things than just that. So you can actually run, reset, self-test, and a continuity all in a line if you needed to. Okay, so now we're going to talk about some calibration. We've got a few things to talk about before we actually perform anything, but one thing that I've done here with my T2 is I've taken the 4110 out of my system and replaced it with a 4110 that is actually out of calibration. So now the maintenance software is noticed that and is telling me about it. So the error you get is external calibration is expired on PPS 4110 chassis 1 slot 15. So first thing you might ask is, where is that resource located within the tester? So if you notice and you look at the bottom left hand corner, you can tell that this block is now red. And so it's telling me that that is the block that has an issue with it at the moment. And so if there are even more modules that were out of calibration, the main page here would list out a few more modules. So again, if we go to the spring pin tab, you can see that there on the spring pin tab. If we go to the chassis tab, you can also see that the instrument in question is also highlighted in red. So again, what it does here is it's telling me, right now I know the instrument's out of calibration, but if it was over temp, or if it had an issue with it or something like that, it couldn't be detected by the maintenance software. Again, this red box would actually signify which instrument. This is nice because once if you need to take the side panel of a tester off to do any maintenance, you don't have to simply count. You can just look at this picture and see which module is actually in question. Same thing for the instrument view tab, right? So you can tell between the two different bays here, I've got one particular instrument that is out of calibration. So if you notice, it says that it's been basically out of calibration for about a year. So it expired last year in 2015. So what we can do now is we can go back to the spring pin tab. And let's go ahead and calibrate this instrument. So for calibration, what you can do, let's talk about the different ways you can do a calibration. Of course, you can select that particular instrument in the drop down here, and you can select what you want to do. You'll notice right now that adjust and verify as left is actually grayed out. So adjusting the instrument means we're actually updating the EEPROM constants on the device. So now what I need to do is actually go to login. So if we go to File, Login, I need to be at a higher level than an operator. So I could be login as a technician, maintenance, engineering, administrator. So I'll go ahead and log in as an administrator. The password is STS admin. And so now that I'm logged in, you'll notice that Adjust and Verify as left is now enabled. The other logins were just simply the password be STS. Again, these passwords may not be true. These are the default passwords. Your IT or your infrastructure teams may change these passwords for your particular test floor. So now I can actually select to do a full DC calibration. So if I select all of my DC calibration options, you notice that Adjust, Verify as left, and Verify as found, continuity, and reset have been selected for me automatically. And the reason it does this is because, again, we need to know that the instrument's in the correct state. We need to check to make sure the pogo pins are okay and the cables are okay. And then we can proceed to do a verify and adjust on the instrumentation. Let me talk a little bit more about some of the different calibration options before we run and do a calibration here. Verify as found uses limits for the STS specifications up to the top plane of the test or the pogo pins. So that verify as found should always pass if it's within its calibration cycle. And then you adjust it, then you do a verify as left. So the adjustment actually uses the DMM in the system to take a measurement and adjust the instrument. When you do a verify as left, we're using tighter limits than the as found limits because we don't have time and temperature to worry about because you just adjusted the instrument. The other option that you can do with the other calibration activity that we have is called self-calibration. So you can do a self-calibration for the whole tester. This is a quicker method. It really just compensates for temperature and time drift. And so that probably takes about 20 minutes for the entire tester. If you were to do a DC calibration of the entire tester, so actually doing a verify as found and adjust and verify as left, this will take hours to complete. Again, it depends on your configuration, so you need to work with your NI field engineers to figure out how long it'll take for your particular configuration. So let's go ahead and verify and adjust this 4110 so we can have it not be read in the system anymore and update the calibration date. So if you select run those actions, the first thing that it's going to ask you is it's going to ask you to confirm the AC power line frequency. So in this case I have it set to 60 Hertz because I'm in the US. Again, please make sure that that line frequency is correct for your particular region. If that needs to be changed, you can contact your admin or an NI STS engineer that's in the field to have that updated correctly. So I'm going to go ahead and hit calibrate. It's going to initial and do the same kind of things it was doing before. Again, I'm going to fast forward this just to make sure we don't take up too much time here in the video. Okay, now you can see that a calibration has actually finished. So again, we can look at the report view here and we can see all the different things that were completed. So you see a verify as found, an adjust, and a verify as left. What you can do is you can actually go look at the summary report, and if you launch this report, it kind of gives you a nice little summary of what we actually went through and actually did, right? So you can see that just calibrating the 4110 took about 200 seconds or so, something like that. So again, you can use this report. It's a summary report that you can use to actually keep with your records and things like that for traceability. What you can also do, there's a detailed summary as well. I'm not going to open these up, but just so you know they're here, there's two other detailed summaries that go through and show you every single data point that we took. So one of the nice things is if you have a question about something that may have failed, you can actually see how much it failed by so that you can help and report to the NI engineers in the field how to help you get it fixed if there's any issues there. So at this point I'm going to go ahead and close this window because it's the same reporting window that we've looked at. And here in just a few minutes the maintenance software has to go and make sure that the date is actually updated on the instrument. And so if we go to the Instruments tab, you should be able to see the date here update in just a moment. Okay, and now you can see the red is gone and the date has updated. So now the new calibration date for this instrument is 5/13 of 2017. And so that's one thing that can be checked to update. So that's the end of the calibration section. The next thing we'll do is RF continuity. Okay, so now what we want to do is check RF continuity in our system here. So one thing we haven't talked about very much in this video is this inner circle here, as you can see, is our RF blind mates. So the outer ring, DC resources and digital, things of that nature, high-speed digital, 200 megahertz or so, and then here in the middle you've got your RF blind mates. So these particular blind mates are part of our RF subsystem that can go up to 6 gigahertz. So what you want to be able to do is check continuity on those as well. You can obviously have the option to hit RF continuity on all connectors. So if you had 8 ports, or 12 ports, or even up to 48 ports, you could check all those at one time. For the purposes of this video, I'm just going to check one. So again, you can use the method where you right click on the particular port you want to check, and you can say RF continuity check. And what this is going to do, so I've already put on my RF continuity or RF calibration load board to do this continuity check. Again, this is a different board than the DC board we were just using for the other routines. Same kind of deal here. It's going to reset the particular instruments we're using, so in this case the VST, and then it's going to go and do continuity. Again, for the purposes of this video, I'm going to fast forward to the routine just to shorten up the video. Okay, as you can see, the continuity test is passed. Again, here in the same window that you can see the different RFs that we did. So BB03, or blind mate 03, is the one we actually checked at this time. Again, you can print off these reports or save these reports as needed. They're all saved in the same directory. So I think the last thing that I'll show you here is the ability to actually go and grab the files from that folder. So if you need to, you can open the report directory, and you can see these are all the reports that we've taken so far today. Again, there's a summary, there's a detailed report, and then a parsable HTML report that can be used. Thank you for taking the time to watch this video about our STS maintenance software. If you have any questions at all, please feel free to contact your local STS engineer or your field sales rep. Thank you so much.